like an example that I asked you to look at. So we'll go over page 381, number 49, and then we'll hit any other questions that you have. So 49, they asked us to do the sine of pi over 6 plus 49,000 pi. Okay. So before we go over this one, let me give you a similar type of question. What if I asked you to do the sine of pi over 6 plus 2 pi? What happens when I add 2 pi? 2 pi is how far around the circle? All the way around one time. It's 360 degrees, right? And we talked about how if you start at an angle and you go all the way around the circle, one complete revolution, you end up in the same spot, right? And the significance of that is that if you're going to end up in the same spot as this, then the sine value for that would be the same as the sine value for just pi over 6. Okay? That's what those coterminal angles mean. It would be in the same spot, so it would have the same y coordinate, right? And sine is the y coordinate. So this isn't 2 pi, but this is 2 pi a bunch of times, right? It's an even multiple of pi. So you're spinning around a whole bunch of times, half of 49,000. What would that be? 24,500 times. But you're still going to end up back at pi over 6. So the answer to this is going to be the same as what the answer to sine of pi over 6 is. So we just need to figure out what the sine of pi over 6 is, and then we'll have our answer. So we'll sketch our XY axes. We'll draw a triangle in the first quadrant because pi over 6 would be in the first quadrant. And have you guys gotten to the point where you see pi over 6 and you think 30 degrees at this point? That's a 30-degree angle. And this is what I'm going to be quizzing you on Friday. I moved it to Friday. I'm stringing you guys along here, but it will definitely be on Friday. If I gave you a 1 right here, could you fill in the rest of the triangle? 2 root 3. Sine is opposite over hypotenuse, so the answer is going to be a half. So it doesn't matter whether they asked you to do sine pi over 6 or sine pi over 6 plus 49,000 pi. As long as this is an even multiple of pi, it's still going to end up at the same spot at pi at the same angle, or not the same angle, the same location, which means the sine value would be the same. So they could have made this 1,000,000 pi or 1,000,000,000 pi. As long as it's an even multiple, it's going to get you back to the same as the sine of pi over 6. All right. So what others do we need to talk about? So do you want to talk about 51 really quickly then? I'll let you look at 50. I included that on our video yesterday. And supposedly they have now whitelisted that channel. It was blocked on the school computers before, but you should be able to get to it on your school computer as of yesterday afternoon. Oh, okay. This is weird. What are we going to do with this? Let's do this. Let's try and rewrite this as I want to think of this fraction right here and try and write it as a mixed number. So what would you get if you divided all these 5s by 2? What would you get? Well, you got your calculators? Get your calculators out. We're going to be using them a bunch today. I feel like we should be able to do this in our head really quickly, but it's all right. My head's feeling a little divided by 2. That is this. Oh, I don't know that I would have come up with that. That is 2,777. It's 2,777,777 and plus 1/2 pi. Right? I would be really happy if this were an even number, because if it were an even number, we could just ignore it, right? Because it would be an even multiple of pi. I guess there would be a, do you see what I did there? I just kind of took this part and wrote it separate from the pi. And if this were an even multiple of pi, we could ignore it, kind of like we ignored this up here. So I'm going to pull another one off of here. I'm going to think of this as the cosine of, so 2,777,776 pi. So there's my whole bunch of times around the circle, but ending up at the same spot. And then I pulled one off of here, so I'm going to put that one onto here. So I've got 1/2 plus another one would be 1.5, right? What's that as a fraction? 3/2 pi. So I'm kind of getting fancy about how I represent this, because I want to try and get this as an even multiple of pi so I can ignore it. Because those even multiples of pi are just going to spin it around and around and around, and it's going to end up right back where it started, which is going to be 3 pi over 2. So now I can just find the cosine of 3 pi over 2. So let me think where that is on my unit circle. So this is 0, here's pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2 is right here. So we'd be looking on our unit circle at a point on the negative y-axis. Sorry, move that up. Get this out. And cosine goes with the x or the y coordinate. This was our big takeaway from our last lesson together. Cosine goes with the x coordinate. What would the x coordinate of a point on the negative y-axis be? 0. So this is equal to 0. All right, I'll let you guys have a look at 50 and 52 after that. See if you can kind of follow along with that. And again, I'm not going to get a chance to check that until probably next class. Other questions from the homework? Thank you for asking about those couple. Going once. Twice. Moving on, folks, we're moving on to chapter 4, section 4. We're going to do this in 2 different days. This is one of my favorite parts of